Hello everyone, good morning. Welcome to Technical Router. Today let us discuss about the memory management. Today let us discuss about the how we are going to manage the memory in Java. There are two types of memories. There are two types of memory, that is a stack and next is a heap memory. There are two types of memory in which Java creates, that are in stack and heap memory. And this JVM manages this both of the memories, and both the memories has been created by the JVM only, and it is stored in the RAM. And this JVM also store in different types of datas. Now, let us see what kind of data is stored in the stack and what kind of data it is stored in the heap. First, let's see what kind of data is stored in the stack memory. This is a stack memory. It makes an copies, and this is a heap memory, which is a bigger one, which is a large and big. This is a stack memory, which makes an copies. The first point, it will store a temporary variable. The stack memory will store a temporary variable and separate memory blocks for methods. The first point is it will store a temporary variable. For example, now in x is equals to 10. Then this x is equals to 10 will be storing in the stack. It will be storing in the stack and it will be a temporary. The life cycle is not a permanent, it is a temporary. Will store here a temporary variables will be storing in the stack memory, and it will be having a separate memory blocks for the method. Now we have n number of methods within the class. For each of the method there will be separate blocks. Interesting. We have an M1 method, it will be storing in this block, and we have an M2 method, it will be storing whatever the variables in that M1 methods or M2 methods. For M1 methods, it will be storing year, and for M2 methods, whatever the variables inside it, it will be going to storing year. It will be having a separate memory blocks each of the method. See, this is for M1 method, M2 method, other methods. Okay, and the temporary variables will be going to storing in the stack. The next point is that it will store and primitive data types. The primitive data types means that int, float, byte, short, double, boolean. These are the primitive data types. Those primitive data types has been stored in the stack. The second point is that will store and will store and primitive data types. This stack is going to store and primitive data types. And the third point is that it will store and object references of the heap. Whatever the object we are going to create, that object will be storing in the heap memory, but their reference is going to store in the stack. The object reference is going to be stored in the stack to store the reference of an heap object. The object which is created, that will be storing in the heap memory, but the reference will be going to store in the stack. Those references can be a strong reference, weak reference, or a soft reference. In that, we have a strong reference. I'll explain each of them. Strong reference, then and weak reference, and then a soft reference. Those references has been stored in the stack memory. each thread has its own stack memory. Each of the threads has its own stack memory. That means that here will be an thread one. Here it is an thread one, and this one be an thread two. This is an thread two, and this one will be an thread three. This is being thread. Each of the thread will be having its own stack. This is on stack 1, this is stack 2, this is stack 3. It will make the copy. I told you starting only this stack will make the copies, and each thread will have its own stack. But this all which thread will store a common heap. The all threads store a common heap memory, but it will be having an own stack memory. The next point is each thread has its own stack memory. Each of the thread will be having its own stack memory, and variables within the scope is only visible as soon as the variable which go on out of the scope, it will get deleted from the stack in the LIFO order. That means a last in first out. The stack will follow an last in first out order. Fifth point, variables within scope is only visible and as soon as any variable goes out of scope means it get deleted. It get deleted, get deleted from the stack in LIFO order. Get deleted from the stack in the LIFO order. And when stack memory is full, it throws a java.lang.stack overflow exception. It will, in the stack is full, it will throw an exception. These are about the stack memory. It will store and temporary variables, and each of them having and separate memory blocks, and will store and primitive data types, and it store an object reference, not the object. Object will be stored in the heap memory, and the references will be storing in the stack memory. And strong weak, I'll explain that. And it will be having, each of them will be having an own thread stack, and variable within the scope will be only visible, and as soon as it goes out of the scope means it will get deleted from in the stack in the LIFO order. If the stack is full, it will throw an stack overflow exception will be throwing. Now I'll explain how it is working. Mm. This is an example. I taken your own example with a class with a main method and primitive data types. I created an object. I taken string literals, and I created an object for other, and I called this method M2 method. I have been called in this M2 method. I have taken an literals and one more new literal strings I have been created. Now I have two methods. The main method is one method, and other one is an M2 method. I told you that each of the method will be having a separate blocks in the stack. For main method, this is an block, and for M2 method, this is an one other block. Each of the method will be having a separate blocks in the stack. Whatever the data it's holding in the main method, that will be storing in this block. The data is there in main method, that will be going to storing here, and this data and M2 method data will be going to store here. The first point is an int x is equals to 10. Int x is equals to 10. It will go store here x is equals to, it going to store here. The first data is going to be stored here. There does not have any object reference. It is not an object. This is a variable. It will going to store in the stack. And next I'm going to create an object. Create an object that is an test t is equals to new test. I told you that the object is going to be created here. The object will be created here. Sorry. In the heap, the object is going to create. This is an object for test object. This is a test object. This is a test object, and that reference, the test object reference t will be storing in the stack. That reference is going to store in the stack. That object reference is going to store in the stack, and that will be pointing out to the heap. Pointing out the heap. And next is a string literal, and this string literal will be storing in the heap in the string pool. It will be a string literal. That is going to store it in the here in this within the string pool. Inside this, inside the value will be storing. This is a string pool. This is a string pool. And that is pointing to string pool. Next I'm going to create an object for the fun method. The object is going to store in the heap, and the reference is going to store in the stack. This is a fun object. This is a fun object, and the reference f, and the reference f is storing in the stack, and it's going to point to that. And next it is that reference is going to call an M2 method. It's going to call an M2 method. This M2 method contain a string literal. Inside it, this M2 method, there is a string literal. And that string literal will hold and same value 45, which is in main method, and it is going to point out for that string pool only. There is no new object for that. It is going to pointing out for that only. And next string literal is going to create a new string. It is going to create a new string. So we have to create a new object, new for a new string pool for an in the heap memory. This is string literal. This is a new string pool. And it is holding 45. This is pointing out here. In this way, we are going to store the data in the stack. In this way, the stack memory is going to have, see, the variable which is going to store in the stack, and method references, the sorry, object references is going to store in the stack, but the object is created in the heap memory, is in the heap memory, and it will pointing to that object. The reference will be pointing to that object in the heap memory, and the string literal, the fun method. And I told you that each method will be having a separate methods. Each method will be having separate blocks. Once you close after here, it will get deleted in the LIFO order. That is a last in first order, which is a last one. This is a string literal. It will be get deleted. Last in first, first will be get deleted once you close the braces, and come next is this one will get deleted. So this two will be get deleted means, and this is also be get deleted. After that will come for a main method. It will come for the main method, which is the last one, the reference of f get deleted, and this is also will be get deleted, and this is also is going to be deleted, and this one is also be going to deleted, and their references also be going to be deleted. Once it is deleted, then the main method, the main will be also going to delete it. Once you close the bracket, the last in first order, the stack will follow in last in first order. Which one is the last, that one will be first is going to be get deleted. And these references also be going to be deleted. This one is also going to be deleted. Everything will be deleted. And what about the heap? Everything will be deleted in the stack, right? Everything will be deleted in the stack. Here also I told, let it, everything will be deleted in the stack. But what about the heap? What about heap? How will the data will be on the object will be deleted in the heap? Those when the scope will be decreases, and in the stack that going to be deleted. This is about the scope. As variables within the scope, it will be visible after the closing of this braces. The scope will decreases, on that time it is going to be deleted in the stack. But what about heap? The garbage collector will delete it. In the heap, the garbage collector will delete, which does not have any references. We'll see is that it does have any references. No, it will delete. This is also does not have any references. Delete it. This one also, everything is going to be deleted by the garbage collector. The object does not have any references means it will deleted by the object collector, sorry, garbage collector. And this garbage collector runs periodically. It will runs periodically, and the JVM control this job, JVM control the garbage collector, how to run it. If the heap is filled, then JVM run the garbage collector fastly. If this is filled, this heap memory is filled means, then the JVM run it fast, and it is not filled means otherwise it will run slowly. Okay, otherwise it will run slowly. These are about the stack. These how the stack is going to, how the stack is working. Okay. These are about the stack. Now let us see how the I told that, and there is an, see, I told there is an strong reference, weak reference, soft reference. I'll explain that now. Here is a stack, and this is an heap. When you create an object, now I'm going to create an object. Fun f is equals to new fun. I told you that the object references will be storing in the heap, but the object references in the stack, but the object is going to store in the heap. Is a fun object. and their references is stored in the stack. Let's see. Here will be that fun references. F is a reference and it is going to point to the fun object. This isn't strong. This isn't strong reference. This isn't. This isn't strong references. When the garbage collector is coming to delete F references, and the strong references will say that don't delete it. I have a strong reference. The next is a weak reference.
Yeah.
Weak person, weak object. Here I have created an object for an weak reference, and this weak reference is going to create here. Here will be weak references, and here there going to be an object. Other object references is going to store here. It is a weak object, and their object will be here. And their object will be storing here, and it will point to here. Hmm. In this way, it is going to point to the weak object from the stack to heap. This is a weak reference. This is a weak references. Now, as soon as garbage collector invoke, it will delete up. As soon as the garbage collector invoke, it will delete of the weak. It will delete of the weak object. When we will remove the object, if you want to access the references, then you will get a null value. When you remove the object, if you want to access the references, if you have to access the references, and that time we are going to get a null value. And that time we are going to get a null value. This is about if the garbage collector invokes and it is going to delete the strong references, means these strong references say that to the garbage collector, don't delete the object references because I have a strong references. On that time, the strong references say the garbage collector, don't delete it. I have a strong reference. These are about the strong and weak. And the one more reason, soft reference. The soft references, and it will say to the garbage collector that you are allowed to delete it if you are very urgent. That strong references will say the garbage collector, you are allowed to delete it if you are urgent and it is filled. If it is only filled, if heap is filled or you're urgent, you can delete it. Otherwise, not. Okay. You are allowed to delete it if you are urgent and it is filled. If the heap is filled or it is urgent, on that time only it is going to delete. These are about the object, that is in strong, weak, and soft references. The next is let us talk about the heap memory. The next second one is an heap memory. This one is also created by the JVM only. And the stack will be following in last in first out order, but the heap does not follow any order for the memory allocation. No order. First point is no order. The first point is the no order. The heap will does not follow any order for a memory allocation. This heap is also divided into two parts, that is an young generation and an old generation. I've already written here, see. This heap is also divided into two parts, that is an young generation and an old generation. And this young generation, it is having an further three types has been deleted, that is an hidden, S0 and S1. This S0 and this S1 are an this one is severe spaces, severe space. This S0 and S1 as a severe spaces. This young generation has been divided further into three. These are three. Now let us create an object. Now let us think we have an object 1, object 2, object 3 and object 4. These are the object I have created. Initially when you create an object, it will going to store in the hidden. See, object 1, object 2, object 3, object 2. Initially it will be going to store in the object will be storing inside the hidden. After some time when the garbage collector invokes, it will do two things. Okay, when the garbage, the first point is first time the garbage collector is going to invoke. When the garbage collector is going to invoke, it is going to do and two things, that it will mark and sweep the algo. It is going to do and two things, that is mark and sweep algo. This mark, this mark will be going to delete the object does not have any references. So let us think this object 3, this object 3 and this object 2. Let's think. This object 3 and this object 2 does not have any references. Okay. If the object does not have any references, then it will be deleted by the mark. Okay. If does object does not have any references, means that will be deleted by the mark, and remaining object will be moved to the S0. The sweep algo will move the remaining objects to the S0. Now here be an, and it will increase its age. Okay. It increase its age. This is an object 1. This is an object 1 and it has its age. Age is be increased. Age is 1. And this is an object 4. This object has an references. This object is 4 and their age is 1. Okay, this object is 4 and they increase their age. This sweep algo move the objects into the S0. It will move the object into the S0 and delete it in the hidden. And delete in the hidden. It is going to delete in the hidden and it increase its age. Increase its age. This process is called as a minor garbage collection. This process is called as a minor garbage collection. Minor GC. This process is called as a minor garbage collection. After some time, okay, here everything will be deleted now. Right? Here there is no nothing will be there. Everything will be deleted. Everything is going to be deleted here. There will be nothing in the hidden. Whatever the references is there, that will be moving to the S to 0 and increase their sign. After some time, the garbage character invoke other time. Okay. After some time, the garbage character invoke. Now I'm going to create some more objects. That object are an object 5, object 6, object 7. Okay. I've created in 3 object and object 8 also. Object 8. Okay. And Again, it will be going to store in the hidden. How many times we are going to create an object? Initially, it is going to store in the hidden. This is an object 5, object 6, object 7, object 8. Object 5. Here will be an object 6. Here will be an object 5, object 6, object 7, object 8. Okay. So again the mark. Again the mark will be going to delete an object which does not have any references. Let's think an object 5 does not have any reference. And object 8 is also does not have any reference. And object 6 does not have any reference. Only object 7 has a reference. Only that object will be moving to the S1. Now it will going to move to the S1, and whatever the object does not have any references, that will be and that will be deleted by the mark, and so it is also moving this object into the S1. Here will be object 7 and with age 1, right? With age 1, here will be an object 7, and object 1 and object 4 also will be moving to the S1 with increase their age. Okay, here will be an this is an object 1 with their age 2. Now initially it has an age 1, and after it is moving to the S1, it will increase their age. That is an age 2, object 4, age 2. Object for age 2. Okay. When the garbage collector invokes other time, I have created an object. Whatever the object is initially there, that will be storing in the hidden. When the garbage collector invoked, whichever the object does not have any references, that will be going to get deleted. Object 5, object 6, and object 8 does not have any references, and those object gets deleted. Whichever the object is having references, and sweep all go. This sweep all go moves this object 7 to the S1, and delete it. Remaining will be deleted in the whatever is there, it will be deleted in the once it's moved, it will be deleted. Will deleted in the hidden, and in S1 it will going to increase their size. Going to increase their size, and whatever the objects is there in the S0, that will be moved to the S1, and that increase their age also. Once again, at third time also it is going to invoke. Third time the garbage collector is going to invoke. I'm creating some more objects. I'm going to create an object 9 and object 10. Initially it is going to store in the hidden only, right? Initially it is going to store in the hidden. Oh, sorry. Object 9 and then object 10. This is an object 9. This is an object 9. This is an object 10. And initially whatever the object we are going to create, that will be going to store in the hidden, and the object does not have any references. Again the mark will be going to delete whichever the object does not have any references. And Here, once it is moved to here, sorry, once it is moved to S1, it is going to be deleted. Once it is moved to the S1, it is going to delete in the S0. Okay, and after that, I have invoked the garbage collector and I created two objects. That objects has been initially stored in the hidden. Whichever the object does not have any object references, that object will be deleted by the mark. The mark is going to delete the object that does not have any references, and sweep is also going to move this object into the S0 and delete it in the hidden. And this object 10 is going to move to the S0 and increase their size. This is an object. This is an object 10 with age 1. This is an object and with age 1. Whatever the object that are present in the S1, that is moved to the S2 and increase their size. Okay, whichever the object. And this isn't for. Once it is moved, it does not have any object references, we're going to delete it. Once it is having object, that is going to move to the S0 and it is get deleted. Okay, and whatever the object that is present in the S1, that object is going to move to the S0 and increase their size. Now this is an, let's think, this is an object 1 with the age 3. Is an object 1 with age 3, and this is an object 7, age 2, and this is an object 4 with age 3. This is an object 4 with age 3, this is an object with age 2. Let's think if threshold age, if an threshold, if threshold age is equals to 3, if threshold age is equals to 3, then that should be promoted. Then they have to be moved into the old generation. Whoever the age is having 3, whoever the age is, object age is 3, that has to be moved to the old generation. Has to move to the old generation. Here the object 1 and object 4 is having an age 3. That will be going to move into the old generation. This process is called as a major garbage collection. Okay, here is an object 4 with age 3 and object age 3. Okay, whichever the we fix that threshold age is equals to 3, whichever the any object that reaches this age 3, that object has to be moved to the old generation, and that process is called as a major GC. That process is called as a major garbage collection. Then these objects in the old generation are big. That are the objects that are there in this old generation. There are lots of objects will be there. Those objects in the old generation will be in big. Okay, these are about the heap memory. Have you? I think so. All of them have understood the memory management in the Java. I'll just brief out it. So this is an there are two types of memory, stack and heap. These are about the stack. It will store and variables and methods. Okay, methods will be having in separate blocks and will be making and copies. It will store primitive data types and an object references, not an object. object will be going to store in the heap, but their references will be there in the stack and will be pointing out to the heap. And each thread has their own stack. Each thread had its own stack and variable scope in within there. It will be visible and it goes out of the scope and is get deleted. Here it is there. See, this is an explanation for an stack. It will be following an leaf order. Whichever the last into the stack, that will be going to be deleted first. Once it is deleted, that that method also be going to delete it and come to the other method. Once the data has been deleted in within that method also be deleted and their object references everything be deleted, and whatever the objects without having references in the heap, that will be deleted by the garbage collector. The garbage collector is going to delete object which does not have any references in the heap, and the AVM will control the how the garbage collector will run. And next reason I told about the strong and weak references. Normally how we are going to create an object, those are strong references, these are weak references, these are weak references. The garbage collector will delete it as soon as the garbage collector invokes. It will delete the weak references, and if you are going to access the object references, we are going to get a null value. We are going to get a null value, and the soft references which it will say the garbage collector to allow to delete it if it is urgent and filled. If the heap is filled or it is urgent, on that time only the soft references will be allowed to delete it. The next is a heap memory. Next is about a heap memory. This heap memory does not follow any order. It is also having in two types, that is an young generation and old generation. This young generation has been deleted. Further three types, hidden, S0 and S1, and how the working process I explained about this. This young generation is called as a minor GC and old generation is called as a major GC. These are about the memory management in the Java, and these young generation are faster, and these are some so based on the objects. Okay, and we'll be having one more here. One more is be there here. It is a meta space. Here will be a meta space. It will be out of heap. Okay, this meta space will be this meta space. This meta space. This meta space will be out of heap, not within the heap. It will be out of heap, and it will store and class variables. It will store class variables. It will store and class variables. Sorry, see. And it is going to store and class metadata. Will store and class metadata, and it is also going to store and constant. A meta space, it will be out of an heap and it will store and class variables, class metadata, and it is going to storing in constants. It's also going to store in constants in the heap. Sorry, outside the heap, that is in the meta space. These are about the memory management in the Java. Thank you guys. I think this video will like you, and please like, share and subscribe if you like the teaching. Thank you. Please support us.